Hello everyone, welcome back. So today we will continue with the questions of set theory. In the previous video, as you know, we have done the sums, the preliminary type of sums of this chapter sets, and also we have practiced few questions on Venn diagram. So from this question onwards, we will do the sums where the properties or the laws are required, like the distributive law, De Morgan's law, associative law, identity laws, which we have learnt previous videos. Those are essential to solve this type of sums. So as you can see on the board, it's written, let A and B be sets if A intersection X equal to B intersection X equals to phi, and A union X equal to B union X for some set capital X. You have to show that A equals to B. As you can understand clearly, this is a subjective type question. The same question can come in objective form also. Like if the question is given in this way, let A and B be sets if A intersection X equal to B intersection X equals to phi, and A union X equal to B union X for some set X, then four options suppose are given, like A equal to B, A not equal to B, A is subset of B, and B is subset of A. This will be the correct option. So if you know the objective type, subjective part, the objective part will not be a problem. So now we will start with the sum. Now, it can be seen that in two parts we will do. Capital A, that is any set, like here it's taken capital A and B, so we are doing with A and B. First we will do with A. Any set capital A that can be written as A intersection A union X. Any set X, A union X. Whatever will be the answer coming in that A union X part, if you find out the intersection with the original set capital A, you will get back that set. It's true universally. So therefore, I have written capital A in this way. So this can be written as A intersection, what is A union X given? That is equal to B union X. This is given. Now here you have to use the distributive law. So this can be written as A intersection B union A intersection X. A intersection B, write it in that way. What is A intersection? A intersection X is equals to what? Phi. So with this, you have to write union phi. So A intersection B union phi. Obviously, you will get that A intersection B. So you are getting capital A is equal to A intersection B. Make this as case 1. In the same way, set capital B, it can be written as B intersection B union X. This can be again written as B intersection. What is B union X? This is equals to A union X. So that you can write. Again apply the distributive law, that is B intersection A union B intersection X. What is B intersection X? This is equals to phi. So this will be B intersection X union phi. So this will be equal to B intersection A. So implies B is equal to, now B intersection A is equal to A intersection B. This is also true. We have done this theorem also. So make this as 2. Look, A is also we are getting A intersection B. B also we are getting A intersection B. So therefore, from 1 and 2, can't we write A equal to B? Comma, can't we write A equal to B? So here is the proof. So we will come to the next question, and this type of question, let's read it first. In a survey of 600 students in a school, 150 are found to take tea, 225 coffee, 100 both tea and coffee. You have to find how many students are taking neither tea nor coffee. So 600 students in a school means the universal set, that is U is 600. So 150 students are found to take tea, 250 coffee, 225 taking coffee. So let's name the sets first. So let's start the sum. Let capital T be the set of students who like tea as because T, so therefore I'm taking the initial as capital T, and C be the set of students who like coffee. So what will be N of T? Therefore, N of T is 150. N means number of students taking tea, that is given 150. Number of students taking coffee, that is given 225. Whereas number of students taking both tea and coffee is given 100. That is T intersection C. Intersection means it has to be present in both the sets. So intersection is 100. You have to find out the number of students who takes neither tea nor coffee. Now we know that we know the formula. N of T union C is equals to N of T plus N of C minus N of T intersection C. This is you have learned in the previous videos. I have taught you the cardinal number of sets, and this is the formula of two sets. Just put the numbers over here. 150 plus 225 minus 100. So that will come equals to 275. So what is this 275? Number of students taking either tea or coffee. That is N of T union C or C union T. So number of students taking either tea or coffee, that is equals to 275. Now what is the question over here? The question is given how many students are taking neither tea nor coffee. Neither means it's the opposite of taking either tea or coffee. So from the original set, that is N of U, you have to subtract this 275. So therefore, let's complete the sum. Number of students taking neither tea nor coffee that is equals to 600 minus of 275, that is equals to 325. This is your answer. Now this entire thing here, as you can see, I have done it by using the formula. Now by Venn diagram, I'll try to show you that what is this exact sum is. Draw the Venn diagram. This is suppose tea and this is suppose coffee. So N of T is 150. So this is 150. This is given 225 and this part, middle part is given 100. So N of T union C, this much we have got as 275. That means this much part. But we have to find out that the students who likes neither tea nor coffee. So this part we have to actually calculate. And the outside set is the U set. U set is what? N of U. That means the universal set, how many elements are there, or here rather how many students are there? 600 students are there. So how to calculate this shaded part? This part, that is N of T union C whole complement. Actually we have to calculate N of T union C whole complement. That will be equals to how much? From N of U you have to subtract, na? So that's why I have subtracted 600 minus of 275, that is equals to 300 of 25, as because the question is given in neither tea nor coffee. If it was either tea or coffee, then you would have ended the answer over to here 275. As because it's a question of neither, so we have to calculate actually the complement part. That's why I subtracted from 600. Hope this sum is clear. So here we come to the last sum of the chapter, and let's read the sum first. In a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both T and H, 8 read both T and I, and 3 read all the 3 newspapers. Then these 2 findings you have to calculate. Number of people who read at least one of the newspapers and number of people who read exactly one newspaper. So let's start with the sum. So how many sets are here? 3 sets are there. So that is H, T and I. So first and foremost, let's start with H. So N of H is equals to how much? That is 25 people read newspaper H. So that is equals to 25. N of I is equals to 26. Similarly, N of T is also given 26. Then N of 9 read both H and I. So 9 is N of both means H intersection I, that is equals to 9. Next, N of H intersection T, that is equals to 11. Next, N of T intersection I, that is equals to 8. And the last one, 3 read all the newspapers. So therefore, N of H intersection T intersection I, that is equals to 3. Now let's come to the first subpart, that is number of people who read at least one of the newspapers. That is, we have to calculate over here N of H union T union I. Why union and why not intersection? Intersection is already given. Now why union? Now we have to calculate what? At least one of the newspapers. It means that the people can read either one newspaper or 2 newspapers or 3 newspapers. So we can easily calculate it on the basis of union. So now you know the formula as N of A union B union C formula, you know. Same formula you have to write, that is equal to N of H plus N of I plus N of T minus N of H intersection T minus N of H intersection I minus N of T intersection I plus N of H intersection T intersection I. Now put the values. This is equals to 25 plus 26 plus 26 minus of 9 minus of 11 minus of 8 plus of 3, that is equals to 52. So this is the answer of subpart 1, that is people who read at least one of the newspapers. Put it in the formula, put the exact values, you will get the answer of this. Now coming to the second subpart. Now for the second one, what we have to find out? We have to find out number of people who read exactly one newspaper, not more than one. This is the difference between the first subpart. In the first one, we had to calculate at least one. Here we have to calculate exactly one newspaper. So for that, we have to calculate n of only h, n of only t, n of only I. So look over here. Let's in rough draw a Venn diagram first of 3 newspapers. This is H, this is T, and this is I. What about n of only H? How will you calculate n of only H? If you find out n of only H is equal to, look, n of H, from n of H if you subtract n of H intersection T minus n of H intersection I plus of n of H intersection T intersection I. Now look over here, let's find out this in the Venn diagram whether whatever I have written it's correct or not. From this whole of n of H, what did I subtract? N of H intersection T. This I have subtracted. Okay. H intersection I. H intersection I means this. This much part I have subtracted. And H intersection T intersection I have added. This much part I have added. So this much part I have. So from the whole of n of H, I have subtracted this, I have subtracted this, and I have added this. So won't I get only H? Only H means this much part. What about only H? It means this much part where I put the dots. This is only H. That means there will be no tinge of T or I. So here just put the values. 25 minus 11 minus 9 plus 3, that is equals to 8. In the similar way, you can find out n of only T. What about only T? This will be n of T minus n of T intersection H minus n of T intersection I plus n of H intersection T intersection I. That will be equals to 26 minus 11 minus 8 plus 3. That will be equals to 10. Now coming to n of only I. In the same way again you can find out n of only I. So what about n of only I? That will be equals to n of I minus of n of I intersection H minus n of I intersection T plus n of I intersection H intersection T. Now that is equals to 26 minus 8 minus 9 plus 3, which is equals to 12. Just by putting the values, you have got the answer. Therefore, number of person who read exactly one newspaper is equals to n of only h plus n of only t plus n of only I. That is equals to 8 plus 10 plus 12, that is equals to 30. So here we get the answer of the second subpart, that is number of people who read exactly one newspaper. So individually I have found out the number of people who read only newspaper H, only newspaper T, only newspaper I. That is, at a time only one newspaper is to be read. So that's why I individually found out only values and then added them up to find out the answer of the second part. So here we end our chapter. If you have any doubts regarding anywhere, kindly write in the comment box. I'll surely answer your queries. So if you like the videos, kindly share and subscribe. Thank you.